There are times that we may not necessarily want the solution to a quadratic equation. We may only want to know if a solution exists, in which case we have the discriminant. The discriminant is just a piece of the quadratic formula. In fact, it's the part of the quadratic formula that lies underneath the radical. So the b squared minus 4 times a times c has a special name called the discriminant. Its value tells us the number of solutions and the type of solutions. Keep in mind, the discriminant does not give you the solutions. It only tells you if a solution exists. If the discriminant is positive, you're going to have 2 solutions. If the discriminant is a positive perfect square, you will have 2 rational solutions. If it's positive but not a perfect square, you will have 2 irrational solutions. If the discriminant equals 0, you would have 1 repeated rational root. If the discriminant is negative, you would have 2 complex or 2 non-real solutions. What exactly does that mean? Think of the discriminant as being underneath the square root sign. The square root of a negative number is not a real number. We say you cannot take the square root of a negative number because the solution is not a real solution. Therefore, if the discriminant is negative, you would say that the quadratic equation has no real solution. More specifically, it has 2 complex solutions. Given the equation 4x squared minus 20x plus 25 equals 0, determine the type of solutions for this equation. Our a is 4, b is negative 20, and c is 25. Plug these into our discriminant formula, which is b squared minus 4 times a times c. Negative 20 squared is a positive 400, and negative 4 times 4 times 25 is a negative 400. So 400 minus 400 is 0. Therefore, there would be 1 rational solution to this equation. Part B, given x squared minus 3 times x minus 8 equals 0, we first have to distribute the negative 3, which would give us x squared minus 3x plus 24. Our a value is 1, our b value is negative 3, and our c value is 24. Plug these values into the into the discriminant formula, and we have negative 3 squared minus 4 times 1 times 24. This gives us a negative 87. Since this is a negative value, you can't take the square root of a negative number because it's not a real number, so we would have no real solutions. However, we would have 2 complex solutions. The discriminant actually tells us the x-intercept of the graph of a quadratic equation. The graph of a quadratic equation is a parabola. If the discriminant is greater than 0, then the graph has 2 different x-intercepts. And the graph will cross the x-axis at the solutions to the equation ax squared plus bx plus c equals 0. If the discriminant equals 0, it will have exactly 1 solution, or exactly one x-intercept, also exactly one solution to ax squared plus bx plus c equals 0. Finally, if the discriminant is less than 0, the graph would have no x-intercepts, meaning the graph would never cross over the x-axis. And to see this in action, use the quadratic formula to solve 3x squared minus 4x plus 2 equals 0. Our a is 3, our b is negative 4, and our c is 2. Plugging these values into our quadratic formula, as we simplify, we find underneath the radical, we end up with a negative 8. If we had used the discriminant first, we would not have gone through the trouble of using the quadratic formula because we would already know that the discriminant is negative, meaning there's no real solution. So while the discriminant does not tell us what the solutions are, it just simply lets us know if there are solutions to the quadratic equation. And if so, how many and what type are they?